Today's goal is to solve trigonometric equations. Let's take a look at this example. If we're solving 3 to the x is 9, well, you know that 3 squared is 9, so x is just 2. And if you're solving the square root of x is 25, you just know that this square, it should have said the square root of x is 5. And you know that the square root of 25 is 5, so x would just be 25. And if x over 4 is 3 over 4, well, x has to be 3. The numerators must match if the denominators already match. You just solved 3 equations without doing any work because you solved by recognizing a mathematical fact. Today, since we're going to focus on key angles in the unit circle, you can simply solve equations by recognizing a mathematical fact. Let me show you an example. If we're solving this equation, sine of theta equals root 3 over 2, that means we want to know what is theta equal to. And we're given this. Theta is, this symbol means an element of. It means theta is a member of the interval from 0 to 2 pi. Brackets, of course, mean we're including 0 and 2 pi as possible answers. So this is giving us a sense of which quadrants we're working in. If theta is between 0 and 2 pi, that means we're anywhere in the unit circle. Okay, and we know that sine is a y value. If it has the value root 3 over 2, well, that must be coming from a pi over 6 or a pi over 3. Well, if the y value is this larger value, it's not coming from a pi over 6 because those have the short y value of 1/2. Okay, and the sine, the y value is positive, so we must be coming from either quadrants 1 or 2 where you're going up. So theta would be simply the angle pi over 3 or 2 pi over 3. You figured out what theta could be by narrowing down your list of options. Let's take a look at another example. If the tangent of alpha, some angle alpha, is -1, what is alpha? And how many possibilities do we have? Well, what do we know about tangent? The tangent of an angle is equal to the sine of an angle divided by the cosine of an angle. And if this is going to equal to -1, well, that means if we cross multiply, or you can get common denominators, we have sine of alpha over cosine of alpha equals -1 over 1. We could, of course, get a common denominator. Then the numerators must be the same. So sine and cosine of that angle have to be the same, except that one is positive and one is negative. So that means we're looking at, well, it can't be a pi over 6 or a pi over 3 angle because those x and y values are different. One is 1/2, one is root 3 over 2. It can't be right on the axes because those x and y values are 0 and 1, which are different, not just by sign. So we must be looking at pi over 4s. But it couldn't be here because here you have a positive x value and a positive y value. So sine over cosine, they are both positive. So we must be looking, here the angle 3 pi over 4 has positive y value and negative x value, both of which are root 2 over 2. So this angle works. It fits our criteria. And so would this angle, whose x value is now positive root 2 over 2, and y value is now negative root 2 over 2. So your two angles, your answers are 3 pi over 4 and 7 pi over 4. You're eliminating possibilities like pi over 6s and pi over 2s by trying to recognize facts that you already know. Let's look at another example. Oops, we didn't quite finish this one. But how many such angles does alpha have? Well, we know for sure of 2 examples, but actually there are an infinite number of possibilities. Because you could say, let me start here, go around the circle a full time, that would be 2 pi, and then land here. So also the angle 3 pi over 4 plus 2 pi. But then you could also say, well, let me just go around the circle twice, 2 pi, another 2 pi is 4 pi, and then land here again. So also 3 pi over 4 plus 4 pi. Or you could say, let me go around the circle twice, 1, 2, and then land here. So that would be the angle 7 pi over 4 plus 2 pi, those two, that full rotation. Or 7 pi over 4 plus 4 pi, 2 full rotations, and then land at 7 pi over 4, and so on and so forth. You could even rotate backwards, because there are an infinite number of times you could go around the circle before you decide to land at either another 3 pi over 4 or 7 pi over 4. There are an infinite number of possibilities for the angle alpha. These are just two specific examples that are in the interval from 0 to 2 pi. Okay, name all angles in 0 to 2 pi. This is a kindness, right? This is saying forget all the infinite number of possibilities you can find by winding around and around and around and around the circle. Just look at the angles in the unit circle such that the tangent of theta is undefined. Well, again, what do we know about tangent of theta? It's sine of theta over cosine of theta. And if it's going to be undefined, that means you're trying to divide by 0. This question is asking the same thing as saying, for which angles theta is the cosine of theta equal to 0? Well, cosine would be an x value. So we want the x value to be 0. It can be here. This is 1, 0, so that didn't work. Oh, but this angle would work. This is the angle with coordinate pair 0, 1. Its x value is 0. So theta could be pi over 2 or 3 pi over 2. Because both have the x value 0, so both have cosine 0. So sine divided by 0 would be undefined. Again, we don't have to consider what would happen if you went 2 pi plus pi over 2, or 4 pi plus pi over 2, or 4 pi plus 3 pi over 2, or something like that, because the directions say we are only focused on angles between 0 and 2 pi. Don't rotate a full circle rotation and then come back. 2 pi would be 1 full rotation. So less than 1 full rotation around the unit circle. Okay, last question today. Name another angle beta such that the cosine of beta is equal to the cosine of 5 pi over 6. Well, 5 pi over 6, it's less than pi, so it must be in the second quadrant. It's going to the left a long distance and up just a short distance, so there's its coordinate pair. And we want the cosine of some other angle to be the same as the cosine of 5 pi over 6, and we know that cosine of 5 pi over 6 is negative root 3 over 2. So we need a negative x value that puts us in the third quadrant, and it has to go over just as far. It can't go over like a shorter distance, so we're ruling out the pi over 4 in there, the pi over 3 in there. So the other angle beta would be 7 pi over 6. Name another, of course you could name other possibilities. It could be 2 pi, a full rotation, plus 7 pi over 6, or something like that. But in this case, we're just looking for one other angle, so we're done.